Welcome to cryptography class. Today I am going to give an explanation about SDES algorithm. The expansion of SDES is a simplified data encryption standard algorithm. So this algorithm which comes under asymmetric block cipher encryption methodology. So compared to data encryption standard algorithm, SDES also implement with plain text and key combinations. The plain text size should be 8-bit and key size should be a 10-bit notations. Then this SDS algorithm will produce an 8-bit of ciphertext value as an output. For decryption also the same methodology will be applicable, in which 8-bit of ciphertext is converted into 8-bit of plain text with the help of same 10-bit. So this is the basic concept behind SDES algorithm. So it is the diagrammatic representation of the basic concept, in which 8-bit plain text, 8-bit ciphertext and 10-bit key will be used for both encryption and decryption purpose. So the same key is used for both encryption and decryption, and the order which is used for conversion of plain text to ciphertext is reversed in the conversion of ciphertext to plain text format. So this SDES algorithm also follows a FESTL cipher structure concept. So it is the overview implementation of the conversion. So in an SDS algorithm, it contains a 4-step process. First step, initial permutation. Then only 2 round functions are available. After that, we should convert a final permutation for retrieving a 8-bit ciphertext from the given plaintext notation. So it is a 4-step process. So these 4 steps are followed in a plaintext side. And at the ciphertext side, if a 10-bit key is given to a round key generator, totally 2 rounds are available. So we are in need of converting this 10-bit cipher key into 8-bit subkey representation. So there is a need of 2 subkeys that should be retrieved from a 10-bit cipher key notation. So at the right side part, the key generation algorithm should be used for retrieving 2 subkeys which each contain an 8-bit size, and those 2 keys are used at 2 rounds. So this initial and final permutation is applicable at the plaintext side. So this is the initial permutation, and final permutation. We are already aware that permutation means shuffling of bits in a given input. So the input for initial permutation is 8-bit plaintext. Final permutation is applied after finding the answer from round 2. So it is also converting 8-bit text into notations. So this is the number. So if you take initial permutation, these consecutive 8-bit values are retrieved from a given plain text, and the arrangements will be written like this. That means 2631, which means that the second bit of plain text should be written first, 6th bit of plain text should be written next, then 3rd bit of plain text value, 1st bit of value, 4th bit, 8th bit, 5th bit, and 7th bit value of plain text should be written like this. So this is the initial permutation. Then after initial permutation, we should apply round 1 and round 2. The output of round 2 is given to final permutation. So round 2 output is also an 8-bit value. So you put the number for those consecutive 8-bit values as 1, 2, 3, 4 like that. And after final permutation, this is the arrangement of values. So the output of round 2 4th bit value should be written first after final permutation. So 4, 1, 3, 5, 7, 2, 8, 6. So in this combination only we should write the final permutation value. So after final permutation, the answer is the retrieved 8-bit ciphertext value. And this is an overview diagram of a single round function. So I already told that SDS algorithm supports two round functions. So this is the first round function output, which means that after initial permutation, total 8 bits are divided into two halves, left half of 4-bit value, right half of 4-bit value. And we should apply the round function only at right half of the plain text. For the round function operation, the first round k1 value is implemented. So the output of round function is XOR with left side value. Then the answers are interchanged. So for round 1, so I am writing the round 1 operation. So for round 1, the input is L0 R0 and the expected output is L1 R1. So from the diagram, L1 is equal to your R0 value and R1 is equal to the input L0 exclusive or of round function of the input is R0 and the first round value is K1. So using this methodology, we should calculate L1 R1, which is the output of round 1. For round 2, the same diagram, but swapping is not available. We just give that concepts as it is. So if you take the input of round 2 is L1 R1. So this is L1 R1. The output is directly given like this. We are not using swapping. So the output is L1 is equal to your L0 value. So this is the output. So output of round 2 is L2. So L2 is equal to L1 exclusive of round function of R1 comma K2. And R2 value is directly applicable from R1. So the diagram is only a straight line for round 2 function. So this is the round function operation. And each round function, there are 4 mathematical operations will be done. It is like the same data encryption standard algorithm format. So the first step is expansion. So the input of right side of 4-bit plain text is given to expansion box, in which it is converted into 8-bit format. Second operation is XOR. So the output of expansion P box value is exclusive OR with K1 at round 1, K2 at round 2. So the same round function is common for both round 1 and round 2. So the output of XOR value is given to S box. So totally 2 S boxes are used at SDS algorithm. So for each S box, 4-bit input is given. The output of each S box contains 2-bit value. So we just combine the consecutive 2 bits of 2 S boxes as 4 bits. Then the fourth operation is permutation. So at that permutation, we shuffle those 4-bit values. Then the output is given to XOR operations for left side or right side, depending upon the round function number. The XOR operation will be done either at left side or at right side. And at the round function, the first operation is expansion. So only we are giving 4-bit as an input to expansion. It will give an 8-bit value. So the 8-bit means each bit is repeated like this. So 4, 1, 2, 3 means 4th bit should be written first, then first bit value, second value, third value. And then the same value, second value, third value, then fourth and first value are repeated. So these 4 bits are double time repeated. So we are having 8-bit value. So this is expansion. XOR operation is the normal exclusive OR operation. So 2 S boxes are used. Each S box contains 4-bit input. So each S box contains 4 values. So here it represents a binary number. So the numbers are 00, 01, 10, 11. In column also, you put 00, 01, 10, 11. So this is the input for SBox 1 and SBox 2. Then, for example, if for the first Xbox, the answer is given like this. So this is SBox 1. So how can we refer means the outer bits value will be taken as row. So row is equal to 1, 1. The inner 2 bits values are treated as column. So 1, 1 means we should refer S1 box 4th row. 0, 1 means we should refer the second column. So the answer is 1. So if you write 1 in a binary format, the answer is 0, 1. So this is S1 box value. Suppose I am giving S2 box input as 0011. So the row value is 0, 1, column value is 0, 1. So you just refer here. So this is 0, 0, 0, 1, 1, 0, 1, 1. In column also you put that number. So row 0, 1, column 0, 1, the answer is 0. So if you write 0 in binary format, it is 0, 0. So if you combine S1 and S2 answer, the output of this S box is 0, 1, 0, 0. In this way, the S box will be performed. Then at the permutation side, only we are interchanging the 4-bit value. So this is the output of round function. So it is an overview of both conversion of plain text notations and subkey generation. So the left side encryption, 8-bit plain text is given to initial permutation first step, then round function 1, shifting, round function 2, final permutation, 8-bit ciphertext. And 10-bit key is converted into shifting format. From the shifting, 8-bit will be applicable. From the 8-bit, we are having K1 and K2 values. So it is also reversed at decryption. So here I am only explaining the plain text to ciphertext conversion part. In the next video, I will explain the subkey generation. That means how the 8-bit subkeys K1 and K2 are retrieved from the given 10-bit key. So I will explain this concept in next video. Thank you.